Hi guys. So I'm going to talk about testing component applications. I'm going to go over why test in the first place, and then talk about end-to-end tests at a high level, some of the benefits and some of the disadvantages. Talk about testing style, because that's fundamentally a new aspect of testing. And then talk about snapshot tests and how you can use them to test your style. And finally talk about unit tests and how to write unit tests for components. So my name's Ed Yerburgh. I'm a software engineer at the BBC. I'm on the Vue core team, and I'm the main author of VueJS Utils, which is the official testing library for Vue. So before we start, we need to answer a question. Why test? To answer that, I'd like to take you back to my first React job about 1.5 years ago. I was working on this large React application, and we were deploying weekly. Part of that deployment process, 3 of us sat down and manually went through a set of instructions and user journeys to make sure that everything was working correctly. This was really time-consuming, right? So there were 3 developers spending 3 to 4 hours just to check that everything was working correctly. And quite often, bugs would still slip through anyway. The problem was we didn't have any tests. We had to do everything manually, and there was just too big of an application to make sure that everything was working correctly by ourselves. So the solution was to write tests. We needed to write tests for our application, but it's difficult to do after the fact. There are a lot of benefits to testing. Firstly, you can check that your application works. You make changes to your code, and then you run your tests, and you can know for certain that your application is still working correctly. Second, if something does go wrong and you've broken a test, debugging it's a lot easier. It's quite easy to pick out what test went wrong, where it went wrong, and how to fix it. Also, it provides documentation. So if you're a new developer to a project and you need to understand how a component or a unit works, you can pick up the test file and see exactly what the developer intended the component to do. And all of this leads to less bugs. A study by Microsoft has found that anywhere from 40 to 80% less bugs result from projects that have comprehensive test suites. So testing's good, right? Everybody knows this. We knew this at my last place, but we didn't have any tests on the front end, and that was the main problem. Testing component-based applications is fundamentally different from testing server-side, and it's a mind switch that we all have to make. We need new ideas. So this is the front-end testing pyramid. It's a way that describes how you should architect your test suites. At the top, we have end-to-end tests. Then we have snapshot tests. And the bulk of our tests should be unit tests. So end-to-end tests are probably the easiest tests to understand. They basically run through user journeys. They're similar to what me and my colleagues were doing when we were running through instructions to test that everything was working correctly. So you might click on a button and then make sure that a modal appeared and that you can sign in correctly on that modal. The benefit of this is that it's testing your whole application. It tests that all of your units work together. It's the closest thing you can get to manual testing. So you're basically telling a browser to do a load of instructions and to make sure that everything's working correctly. And finally, they're easy to understand. So you can share your end-to-end tests with product owners and your project manager to explain where you are in the project. But there's some downsides. They're slow. If you've got a large set of end-to-end tests, like we have at the BBC, they could take anywhere from 20 to 40 minutes to run. This leads to a very slow iteration between your development and your actual feedback from the tests. Also, if one does fail, it's difficult to debug it. If it's running on a server in the cloud and you get a failed test back, you're going to have to start up the browser yourself, open up the test, and go through the user journey yourself, which takes several minutes. And also, they don't test style. So testing style is a tricky topic. It's almost impossible to test style with unit tests alone. You could have unit tests for every single class in your component, but you'd end up with like 3,000 unit tests for a large application. The way that you can test style is by using snapshot tests. So hands up if you've heard of snapshot tests. Okay, most of you, right? So back in the old days, we used to have snapshot tests where we'd spin up the whole application, take a picture of it, and compare it against a previously saved picture. But recently with Jest, we can actually compare strings. So we can render our components into a string, save that as a snapshot, and then compare it each time we run our tests. So what this enables us to do is make sure that the tests contain the same classes that it had previously. When you're styling a component, there's a manual element to it. You style the component and then you check that everything looks correct. What a snapshot test does is it's almost a safeguard against anything being deleted from your component that would change how it's styled. So say you finish styling a component, you've added your classes, you forget about it, and then someone else comes to the project and accidentally deletes a class or a piece of markup that would affect the styling of your code. If you have snapshot tests, this will fail when you run your test suite and tell somebody that they need to look at the component and check that it's still rendering the style in the right way. So snapshot tests check that a component hasn't changed since the last time you check it, and that's the main benefit that they give. They stop any accidental style changes and they prompt developers to make sure that everything still looks as it should. The benefits of snapshot tests is that they're easy to set up nowadays with Jest. You just call the function and Jest does all the rest of the work for you. It also covers a lot of code. When you have large 100-line components, you don't want to be unit testing every single line, or you're going to end up with brittle tests that make development slow. When you've got snapshot tests, you can cover a lot of lines with minimal overhead. And finally, the biggest benefit, like I said, is that they catch style changes. The downside of snapshot tests is that it's easy to add incorrect snapshots. So you need to check that the original snapshot that you've added is correct. Otherwise, you might be testing against a buggy snapshot. Also, if you add too many snapshots, if you have 6 or 7 snapshots per component, then your test output is going to get really noisy. You might end up with 30 or 40 failed snapshots when you run your test suite. And nobody's going to look through each of those snapshots to check that everything's correct. So the key to having a decent snapshot test suite is only having maybe 1 to 3 snapshot tests per component to make sure that you still are prompted to look at the component when you make any changes. So finally, you come to unit tests, which are the meat of any component-based application. The benefit of unit tests is that they're granular. They test the small details of your project. They also run quickly, so you could have a suite of 5,000 unit tests running in 30 or 40 seconds. And when they fail, they're really easy to debug. This leads to a quick iterative cycle when you're developing your code. And the only downside I can think of unit tests is that they don't test the integration of units. But if you supplement your unit tests with end-to-end tests, you should have this covered. So how do you write unit tests for components? When you write unit tests for modules, you simply call the function, pass in some parameters, and expect the return output will equal a certain value. You trigger an input and you expect an output. But components have a different input and a different output to regular functions. The input for components could be user actions, like a click on a button or the change of a form field, or props that you pass down to the component. The output of a component, ultimately, is the render function. That's the function that generates the virtual DOM, that generates the actual DOM node that's added to your application. And some component frameworks like Vue, for example, also output events. So you know that you need to trigger an input and expect an output, but how do you know what to test? You don't want to write unit tests for 100 lines of markup. To decide what you should test, you could use something called a component contract. A component contract defines the expected behavior of a component and what assumptions are reasonable to have about its usage. You can think of it as an agreement between your component and the rest of the application that says, if you put me here and you give me this input, I'll render this output. Component contracts help us avoid testing implementation detail. For example, a lot of tests that I see with React or Vue applications might assert that a change, say we're testing a counter component, they might trigger a click and expect that the state of the counter component has changed. But this is testing implementation details. You shouldn't care what the state of a component is. You only care about its ultimate output, the markup that it renders. When you think about a component contract, you think that the ultimate agreement between your component and the rest of the application is this output, which means that you won't test any implementation details because it's not part of the output. What this also means is that you can use classes in your test. So I see a lot of people concerned with using classes, and they worry that they're testing the implementation detail. Some people even add attributes specifically to enable them to test their components without tying themselves to any details. But when you're testing the class, when you're testing the render tree, you are testing the output. You're not testing implementation details at all. So I always encourage people to use classes or markup as selectors inside their unit test for components. Finally, I say in the front end, you don't need integration tests. Integration tests' main benefits is that they integrate units together. But that's in a world where you're testing units in complete isolation. In the front end, it's pretty difficult to test things in isolation. You're ultimately always using a DOM. When you render a component's output, you're using the DOM API. A lot of components use browser APIs all the time. So using integration tests is a pretty fruitless activity. A better way to think about it is to just lump all of your integration tests in with your unit tests. A lot of people have different ideas about what a unit test is and what an integration test is, and this can cause arguments in development teams. So an easier way to go about it is just to write unit tests that might sometimes be integration tests, but just make sure that they run quickly. So yeah, before I finish the talk, we'll just go over this front-end testing pyramid again, which describes what percentage of your test suite should be made up by certain tests. Like I said, you want your end-to-end tests as a small percentage that run against your whole application and check that everything works together. And then you can use snapshot tests to make sure that no style changes happen accidentally. And finally, you've got your unit tests that might contain integration tests that make up the bulk of your application's testing suite. So that was it for my presentation. I've actually written a book about testing VueJS applications, and I write a lot about these ideas in that. So if anybody is interested, it's out now, and there's a link at the bottom. I'll share my slides around after the meetup. Cool. Thanks, guys. Thanks for having me talk.